Lesson 5, permutations with different cases. A case means that there's multiple different options in which you could be doing something. So there's certain cases that are boundaries on when you're doing a permutation. So Tanya needs to create a password that she can use the digits 0 through 9 and any letters of the alphabet. The password is case sensitive and must be at least 5 characters to a maximum of 7 characters. And each character can only be used once in the password. How many different passwords are possible? So first let's decide how many different options there are for a password. So there's 10 different numbers. There's 52 different letters because it's case sensitive. So if it's a capital, it's different than a lowercase. So altogether, there are 62 options for something to put into your password. And she can have between 5 and 7 characters. So we have 3 different cases. The first case is if she has 1 or 5 characters. So there's 5 letters in her password, or 5 letters or numbers. Case 2 would be that there's 6 digits in her password, and case 3 would be if there's 7 characters in her password. So for the first one, our n is 62. For case 1, we have 62. We're picking 5 of them because the order matters. For case 2, there's 62. We're picking 6 of them. And for case 3, there's 62, and we are picking 7 of them. And because each of these is its own separate case, we want to add all of these options together because each one makes its own distinguishable set of passwords, so we have to add them all together. So we're going to type into our calculator 62P5 plus 62P6 plus 62P7, and you will get a very large number. And this is why it's very difficult to hack passwords when you have a very strong password. And I don't even know what number that is. 2,523,690,780,000. That is what that number is. So there is so many different passwords. Example 2, at a used car lot, there are 7 different car models, and they're to be parked on a street for easy viewing. The 3 red cars must be parked so that there is a red car at each end, and the 3rd red car is exactly in the middle. How many ways can they be parked? So we've got 7 cars, and 3 of them are red. So this is a red, this is a red, and this is a red, because they want the reds on the end and in the middle. So we have 3, 2, and 1. There's 3 available here, 2 available here, and 1 available here. The rest are different cars, so we'd have 4 available here, 3 available here, 2 available here, and 1 available here. So what we're going to do is we're going to have 3 of them, and we're going to choose all 3 of them. And we're going to multiply 4 of it and choosing 4 of them, which is the same as 3 factorial times 4 factorial, which is 144. So there's 144 different arrangements with the red cars on the end and in the middle. For part B, they want to have 3 red cars parked side by side. So if we think about that, 3 of these red cars have to be parked side by side. So if we just looked at the blue spaces, we have 1, 2, 3, 4, 5 different options. This is the same as 5 times 4 times 3 times 2 times 1. So there's 5 factorial ways to arrange the 3 red cars in there. But we also can arrange the 3 red cars in different ways. We can arrange them in 3 times 2 times 1 different ways. So we also have to multiply this by 3 factorial. So we have 5 factorial times 3 factorial. There is 720 different arrangements. Example 3, a social insurance number consists of a 9-digit number that uses the digits 0 through 9. For part A, if there's no restrictions and each number can be repeated, how many sins are possible? So there's 9 digits, and each one, there's 0 to 9, so there's 10 different options. So if numbers cannot be repeated, that's the same as 10 times 10 times 10 times 10, all the way to the power of 9, which is 1 billion. So there's a billion options for social insurance numbers using the digits 0 through 9. If no repetition is allowed, we would have to use our permutation. So we have NPR. N is equal to 10 because there's 10 different digits, and R is equal to 9 because we're choosing 9 of them. So we have 10 pick 9, which is the same as 10 factorial over 10 minus 9 factorial, which is 10 factorial over 1 factorial, which is 3,628,800. So that is how many options there are if you can't use the same number twice.